What if I told you that for decades, the universe has been hiding half of everything that should exist? Not dark matter, not some exotic particle, but the regular stuff that makes up you, me, and every atom we've ever touched. Scientists just found it all. And where it's been hiding changes everything we thought we knew about how galaxies work. Here's what makes this wild. Physicists have known since the 1970s exactly how much normal matter the Big Bang created. The math is bulletproof. 5% of everything in the universe should be regular atoms. But when astronomers counted up all the stars, planets, and gas clouds they could find, they came up short. Way short. Half of all the atoms that should exist were just gone. Think about that. Half of all the protons and neutrons created at the beginning of time. Missing. Not destroyed, not transformed into something else. Just unaccounted for. Like doing inventory at a warehouse and realizing half your stock vanished without a trace. The hunt for this missing matter became one of astronomy's most frustrating mysteries. Scientists had a pretty good idea where it might be hiding. Computer simulations kept pointing to the same place, the vast, nearly empty spaces between galaxies. But there was a problem. This matter was predicted to be so hot and so spread out that it was essentially invisible. Imagine trying to find steam in a room the size of a stadium, except the steam is 1,000,000 degrees and there's only one molecule per cubic meter. For 20 years, astronomers tried everything. X-ray telescopes looking for the faint glow of superheated gas. Nothing conclusive. Studying how light from distant quasars got absorbed. A few hints, but not enough. The matter remained stubbornly hidden. Then came the breakthrough nobody saw coming. Fast radio bursts. These are millisecond flashes of radio energy from distant galaxies, so powerful they can briefly outshine an entire galaxy. We still don't fully understand what causes them. Probably neutron stars with magnetic fields 1 trillion times stronger than the sun's. But here's the genius part. You don't need to know what makes them to use them. When these radio flashes travel billions of light years to reach us, they pass through all that supposedly empty space. And that space isn't empty. The missing matter is there, just incredibly thin and hot. As the radio waves pass through, the electrons in this near-invisible gas slow them down. Different frequencies slow down by different amounts, like light through a prism. By measuring this delay with extreme precision, astronomers can essentially weigh the void. The new study, published just days ago in Nature Astronomy, used 69 of these cosmic flashlights from across the universe, some from just 12 million light-years away, others from over 9 billion. Each one probing a different line through space, building up a complete picture. The results? Mind-blowing. 76% of all normal matter in the universe is floating in the spaces between galaxies. Another 15% surrounds galaxies in extended halos. Only 9%, less than 1/10, is actually inside galaxies forming stars and planets. Let that sink in. Over 90% of all the atoms created in the Big Bang never made it into galaxies. They're out there right now, spread so thin you'd need a box the size of an office to find a single atom, heated to millions of degrees, completely invisible to our eyes. But here's where it gets even more interesting. This isn't just about solving a cosmic accounting problem. This discovery confirms something profound about how galaxies actually work. Galaxies aren't just passive collectors of matter. They're violent, dynamic systems that blast most of their material back into space. Think of it like a cosmic thermostat. Gravity pulls gas into galaxies, but then massive stars explode as supernovae, and supermassive black holes shoot out powerful jets. These forces heat the gas and blow it clear out of the galaxy, spreading it across millions of light years. The violence is so extreme that galaxies essentially regulate themselves, preventing too much matter from accumulating. This explains a huge puzzle in astronomy. Simple physics says galaxies should be much bigger and full of old stars. Gravity should just keep pulling in more and more gas until you get these massive, bloated galaxies. But that's not what we see. Real galaxies are smaller, more spread out, with ongoing star formation. Now we know why. They're not hoarding their matter, they're spraying it across the universe. Of course, like any good scientific discovery, this raises new questions. The study has limitations. 69 data points probing the entire universe is impressive, but it's still a tiny sample. Each fast radio burst gives us one thin line through billions of light years of space. It's like trying to map an entire ocean by dropping 69 weighted strings. There's also the technical challenge of separating the signal. When astronomers measure how much the radio waves slow down, they need to subtract the effects of our own galaxy and the galaxy where the burst originated. These estimates introduce uncertainty. Get them wrong, and you might be measuring matter that isn't really in intergalactic space. And then there's the uncomfortable fact that we still don't fully understand what creates fast radio bursts in the first place. We're using a phenomenon we can't completely explain to measure something we can't see. It works, the math checks out, but it's a reminder of how much we still don't know. A recent analysis even found a mathematical error in the original technique from 2020. When corrected, the measurements actually match other cosmic observations even better. Science progressing by finding and fixing its own mistakes. The real excitement is what comes next. New radio telescope arrays are about to come online that will detect 10,000 fast radio bursts every year. Instead of 69 lines through the universe, we'll have thousands. Enough to create actual three-dimensional maps of where all the matter is, how it flows, how it connects galaxies across cosmic time. These maps could help solve even bigger mysteries: the rate the universe expands, the nature of dark energy, even the mass of neutrinos, those ghostly particles that barely interact with anything. All of these fundamental questions might be answered by mapping the cosmic web of missing matter. It's a perfect example of how science actually works. A decades-old mystery solved by a completely unrelated discovery. Using mysterious flashes from distant galaxies as cosmic flashlights to illuminate invisible gas. Finding that the universe is far more violent and dynamic than we imagine, with galaxies hurling most of their matter into the void. The missing matter was never really missing. It was there all along. We just needed the right way to see its shadow. And what we found tells us that galaxies aren't islands in empty space. They're connected by a vast web of superheated gas, constantly exchanging matter in a cosmic dance of gravity and explosive feedback. Makes you wonder what else is out there, hiding in plain sight, waiting for the next clever technique to reveal it.